the invisible shield that protects us. Imagine an Earth without a magnetic field, without protection from the solar wind, without a compass, without stable navigation. What if one day it disappeared or started behaving unpredictably? Every year, scientists record anomalies more and more often. The South Atlantic anomaly is expanding. The northern magnetic pole is rapidly drifting towards Siberia, and the field strength is decreasing. What is this, the beginning of a geomagnetic inversion or something completely new? The Earth's magnetic field is one of the most mysterious and important components of our planet. It is invisible, but vital. In this video, we take a fascinating journey deep into the Earth's core to understand. How is the Earth's magnetic field formed? Why is it weakening, and what is the South Atlantic anomaly? Is a pole shift possible in the near future? What will happen to mankind if the magnetic field disappears? Fasten your seat belts. We begin our dive into the deepest and most mysterious processes that shape our world. How does the Earth's magnetic field work? The magnetic field is created by geodynamo, the movement of molten iron in the Earth's outer core. These movements create electric currents, and the currents in turn generate a magnetic field. It extends far beyond the planet, forming the so-called magnetosphere, an invisible cocoon that protects us from the solar wind and cosmic radiation. Interestingly, the magnetic field is constantly fluctuating. It strengthens and weakens, changes shape, and even flips over. Scientific data confirms that magnetic inversions have already occurred in the Earth's history, when the North and South poles changed places. What is happening to the field today? Over the last 200 years, the strength of the magnetic field has decreased by about 9%. That's not just a statistic, it's a troubling symptom. Scientists are particularly concerned about the South Atlantic anomaly, an area over South America and the South Atlantic where the magnetic field is particularly weakened. It is in this region that satellites fell more often and the radiation impact on them increases. Some scientists believe this is a sign of an inversion that has begun. Others say it's a temporary anomaly. But a growing body of evidence suggests the magnetic field is behaving erratically, and the consequences could be serious. The poles are on the move. The magnetic North Pole, which was still in Canada at the beginning of the 20th century, is now rapidly moving towards Siberia. Its speed has more than tripled from 15 km or year to 50-60 km or year. Scientists from the U.S. Geological Survey and the Alvin Institute of Geophysics are watching this process with alarm. Such a shift could affect navigation systems, aviation, satellites, animal migrations, and even climate. And if the inversion really begins, we will be witnessing a grand but dangerous phenomenon. New alarming signals. The Earth's magnetic field, which for billions of years has protected life from cosmic aggression, is now beginning to behave strangely. Scientists from around the world are watching this process with alarm. Back in 2020, satellites of the European Space Agency's Swarm mission recorded serious deviations in the structure of the field. A particularly mysterious zone is the South Atlantic anomaly. Here, the magnetic field is weakened so much that spacecraft literally sag in their defense. Some of them even fail because of the increased flow of radiation. It's been called the Earth's weak spot. But what is even more surprising within this anomaly began to form a second point of minimum. That is, the area where the field practically disappears. This could be a sign that a geomagnetic inversion is not just possible, but has already begun. Pole drift, an acceleration not expected. The North Magnetic Pole is leaving Canada and rushing towards Siberia at a speed of up to 60 kilometers per year. For comparison, at the beginning of the exact century, its speed was only 15 kilometers per year. This process has accelerated so much that international services had to urgently update navigation maps and programs. But why is this happening? The magnetic field is created deep underground in the outer core, where liquid iron and nickel form giant currents. When those currents change, the magnetic field changes. And since we cannot look there directly, all that we see, this is only the surface manifestations of much deeper and still incomprehensible processes. The pole shift is already affecting aviation, navigation, and even the migration routes of animals. Some species of birds and sea creatures are losing their orientation. This may seem like a small thing, but at the level of the biosphere, it is a wake-up call. What if the magnetic field disappears? The complete disappearance of the Earth's magnetic field is a rare but theoretically possible scenario. Although in practice, it would likely just weaken greatly, the consequences of even a temporary disappearance would be catastrophic. Let's imagine there is no longer any magnetic shielding on the Earth's surface. What's in store for us? Radiation shock. Solar wind and cosmic radiation reach the surface unhindered. Ordinary magnetic storms become deadly. This leads to an increase in cancer, mutations in DNA, massive reproductive failures in animals and humans, collapse of satellite systems, navigation, meteorology, internet, military systems all operate through satellites. In the absence of a field, electronics overheat, atmospheric ionization increases, and satellites fail one by one. Power problems. Magnetic storms are already capable of causing power grid failures. If there is a strong inversion or the field weakens by a few percent, the consequences could include nationwide power outages, transformers failing, communications and internet outages, climate fluctuations. Although a direct link between the field and climate has not yet been proven, there is evidence that dramatic changes in temperature patterns and air mass circulation have occurred during past inversions. Psychophysiological impact. Some scientists and alternative researchers claim that the magnetic field affects brain rhythms, biorhythms, mood, and even time perception. When the field is weakened, anxiety, sleep disorders, and depression can increase. It's happened before. The history of geomagnetic inversions. Magnetic field inversions are not science fiction. They are a documented geophysical fact. Over the past 20 million years, the Earth's polarity has reversed more than 80 times. The last major inversion, the Bruns-Matsuyama inversion, occurred about 780,000 years ago. Then the north and south magnetic poles literally switched places. The transition took several thousand years. But there were also faster, shorter-term events, geomagnetic excursions. For example, the Lecampa event about 41,000 years ago lasted only a few hundred years. The field intensity dropped to almost 5% of normal. What's interesting, this event coincides with a number of climate anomalies and the extinction of some species. Some scientists even believe that this is when Neanderthals began to disappear, giving way to Homo sapiens. Humanity survived. But back then, it was not technologically dependent on power grids and satellites. Today, the situation is quite different. Magnetic field and technology on the verge of failure. Modern civilization means thousands of satellites, millions of kilometers of cables, sophisticated navigation and communication systems. All of this is vulnerable. Even a slight weakening of the magnetic field can cause massive GPS failures, especially in aviation and military applications, affect cell phones and the internet, increase errors in navigators in cars, airplanes, ships, disrupt financial systems and bank servers, endanger astronauts and manned missions into space. Polar regions, where the magnetic field is already weaker, are especially sensitive to these phenomena. It is there that disruptions in satellite communications and failures in electronics are already being recorded. Despite all the warning signs, mankind is already thinking about defense. Scientists, engineers, and international agencies are developing scenarios to adapt to a possible inversion or weakening of the magnetic field. Infrastructure protection. Magnetic shields on satellites. Many satellites are already being equipped with additional radiation shielding. In the future, if the field weakens, such measures will become mandatory. The development of special miniature magnetic fields around satellites is possible. Redirecting satellite orbits. If it is known that the magnetic field is weaker in a particular area, for example, the South Atlantic anomaly, satellites can be reorbited in advance, either temporarily or permanently. Underground storage and backup systems. Underground data centers, shielded from external radiation, are being established to protect critical information, especially government data. Medical adaptation. Magnetically shielded chambers. These technologies can be used in space, in underground laboratories, and in medical centers. The chambers shield against radiation and maintain a stable magnetic environment, which helps reduce stress and physiologic strain. Anti-radiation drugs. Scientists are working on substances that increase the body's resistance to ionizing radiation. This research is funded, among other things, in preparation for future space missions. Scientific monitoring and response. Monitoring networks. Worldwide agencies such as ESA, NASA, and university laboratories monitor geomagnetic activity 24 hours a day, 7 days a week. Rapid warning centers for storms and anomalies are established. Response protocols. Guidelines are being developed for energy companies, airlines, military, and rescue services. In the event of a magnetic anomaly, risks can be mitigated in advance. Shut down sensitive equipment, change routes, limit activities in dangerous regions. Magnetic field and biosphere. We're used to thinking of the magnetic field as something technical, but in fact, it affects the entire biosphere, including animals and possibly even humans. Animal migrations. Many species are oriented by the magnetic field. Birds, geese, pigeons, storks, sea turtles, salmon, bees, even bacteria. They have special cells or molecules in their bodies that are sensitive to the magnetic field. If it changes, animals can go off course, fail to find a breeding ground, or die along the way. Geomagnetic sensitivity in humans. So far, this question is controversial, but some scientists suggest that humans also sense the magnetic field subconsciously. There are hypotheses that changes in the geomagnetic environment can cause headaches and anxiety, sleep disturbances, decreased concentration, spikes in aggression or depression in years of increased solar activity. Heart attacks and traffic accidents are reported to increase. Does the magnetic field affect the climate? Official science has yet to give a direct link between geomagnetic changes and climate change. However, interesting correlations are emerging. During the Lecampa event 41,000 years ago, there were climate anomalies, cooling, and mass extinctions. As the field weakens, the inflow of cosmic radiation increases, which can change cloud cover and hence temperature. The magnetosphere is involved in protecting the atmosphere from ionization, affecting the processes on which the circulation of air and water depends. It is also worth noting that the magnetic field can interact with solar activity, and that, in turn, affects climatic processes on Earth. So far, these are just hypotheses, but more and more scientists are paying attention to them. Alternative hypotheses and mysteries. When it comes to magnetic fields, there are not only scientific theories, but also hypotheses that go beyond academic science. Magnetic field as a carrier of information. Some researchers believe that the field can preserve the fingerprints of evolution. That is, it is not just a protection, but a kind of energy memory of the planet. This idea sounds almost mystical, but finds support in theories about the holographic nature of the universe. Field and consciousness. Supporters of this idea claim, during strong geomagnetic storms, people have more vivid dreams, intuition increases, and unusual states of consciousness arise. There are even studies linking the level of geomagnetic activity with mass moods in society. Cosmic cycles. Some scientists hypothesize that changes in the magnetic field are due to the solar system passing through different parts of the galaxy. For example, through spiral arms where there is a higher density of stars and radiation. This may explain regular geomagnetic inversions and climate crises on the planet. Esoteric versions. In esotericism, there is the notion that the magnetic field restrains higher forms of energy, and its weakening would open a window of opportunity for a new era of consciousness. Such ideas are popular in spiritual circles and futurological theories. The magnetic field is not just a physical phenomenon. It is an invisible shell that has protected life on Earth for centuries. It's a cosmic barrier keeping chaos out of the atmosphere, but today, that shield is faltering. We are witnessing its instability. Perhaps an inversion is coming. Perhaps it's just a temporary anomaly. Science has yet to provide definitive answers. But one thing is certain: all life on this planet depends on this delicate, fragile structure. And the further we advance in technology, the more we realize we're vulnerable to it. Doesn't matter how powerful our computers and rockets become if the magnetic field disappears. The basis for stability disappears. But there is another side to this. We have the brains, the knowledge, and the combined science to not just predict, but to act. We have a chance to not just survive, to adapt and become stronger. Today, we stand on the brink of change. We face not only a challenge, but also an opportunity to better understand how the Earth works, and maybe the whole universe. If you are close to science, if you feel at the greatness of the planet, if you want to know what will happen next, stay with us. There are more mysteries to come, and perhaps the most important discoveries are yet to come.